Okay, so let us continue. So using a quarter, you can also integrate using just a quarter. Integrate this one since we've got is divided into 4 parts, so we can multiply 4. Yeah, when you get just this small integral. Okay, so I'm going to use the same approach. So here is a function that we have in terms of y. But now if you get the triangle, we know where the radius is, which is actually the right angle triangle, and then we also have x there. So if you check properly, you find that this other side is supposed to be square root of r, then square minus x squared. Okay, now if you have got an angle, then sine theta should be x over r. I want to make sure that I eliminate these values of x so that we remain with simply r. Okay, so that's why I'm introducing the angle theta. So it's going to be like that. Then cos theta is supposed to be adjacent over hypotenuse, which is going to be like this. So if you make x the set formula, then it's going to be r is equal to r sin x is equal to r sin theta. Then okay, then you can differentiate this one, which is going to be because we want to find the dx here. So when you find dx, it's going to be dx over d theta. It will be r cos theta, and therefore dx is going to be r cos theta d theta. Then the other one, if you cross multiply, it's going to be r cos theta is equal to r squared minus x squared. Now that we know that dx, where there's dx here, we are going to replace it with the r cos theta d theta. So I'm going to put d theta there. Okay. Then where there is this function, I'm going to replace with this one. And that's why you are saying there. And then if you multiply r squared, r times r is going to be r squared. Then cos times also going to be cos squared theta d theta. Okay. Okay. So from there, so what I did was, now we have changed the function. X is equal to r. And x is equal to, so these are the limits. Okay, now this one is purely a constant, so we can take it out of the integral, and then we have that, so that we remain with the cos squared theta d theta. So now we can do some trigonometric substitutions. We know that cos 2 theta is equal to 2 cos squared theta minus 1, which you can actually write as cos squared theta is equal to 1 over 2, then cos 2 theta plus 1 d theta. Then you can bring this function here. You can bring this function, which is half cos 2 theta plus 1 d theta. But we know that 1 over 2 is also a constant. You can take it out so that it will reduce this. So if we integrate this one, cos 2 theta is going to be 1 over sin theta plus theta. Then taking the boundaries, if we take the boundaries, that's pi over 2, and then the 0, and then we substitute the upper limit into this. This one automatically it will actually become 0. If pi theta, it will actually become 0. Yeah, and then this one where the theta, put theta, so the entire function here will actually remain with the simply theta over 2. But this one, everything here will actually give us a 0 if you now plug in the lower limit. And then, so we're going to remain with pi over 2. You multiply by 2r squared, the 2 and the 2 cancel, and then we're going to remain with pi r squared. Therefore, area is equal to pi r squared.